Hello everyone, welcome to the flipped lesson on solving more complex quadratic systems with me, Mr. Wykhorst. As you watch this video, please take notes on what you see. You may rewind and rewatch as much as you need to, and write down any questions that you have about the content of the video that aren't answered in this video. Before we could get started on solving more complex systems, I want you to imagine that you have a graph of a circle and a parabola or a line. How many possible solutions can there be? Come up with as many examples as you can. So pause the video and try to draw as many examples of a circle and a parabola and a circle and a line as you can. Okay, let's see what you came up with. You should have come up with examples like you see on my screen. So when you have a a circle and a line, there's actually three possibilities. You could have one solution, like you see here. You could have no solutions, or you could have two. If you have a circle and a parabola, there's actually several different examples. You could have one solution, two, you could have three, four, or none. And those are all the possibilities. What I'm going to teach you how to do in this video is how to solve a system that involves a circle and either a line or a parabola algebraically. Before we can get into that, we need to talk about what the standard form of the equation of a circle is. We're not going to worry about how to graph circles yet. We're just going to worry about what its equation is and how to use it to solve things algebraically. So you can see on the screen that the standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. The values of h and k are the center of the circle, and r is the radius. Okay? We saw h and k when we did vertex form of a quadratic, and here we're seeing it again. So if you get a system that has these types of functions, these types of circles, to solve them, you're going to use the substitution method that we have used for other systems. It's just going to look a little bit different. So in order to get comfortable with this, let's look at an example. We're going to solve y equals x squared and x squared plus y minus 2 squared equals 4. Okay? So if I want to solve, I want to identify the values of x and y where these graphs will intersect. Just a quick fun fact, this circle, the second equation, has a center at 0, 2, and has a radius of 2. So if you wanted to actually graph that, you would plot the center at 0, 2, and then use a compass to make sure that the radius is 2. But we're going to focus on how to solve this algebraically. So in looking at the top equation, I see y equals x squared. All right? So this equation is what I'm going to use to substitute into the other one. So since I know that y is equal to x squared and x squared equals y, I can make a choice here. I can either substitute in x squared for y, or I could substitute in y for x squared. To make my life easier, because I already predict what's going to happen, I'm going to take x squared out of the second equation, and I'm going to put y in its place. So that second equation, x squared plus y minus 2 squared equals 4, will now become y plus y minus 2 squared equals 4. So now that I have that, what I need to do is try to solve for y, since I now have one variable. So in order to do that, I'm going to expand the y minus 2 squared. So I'm going to take care of that. And if I expand out y minus 2 squared, I'll bring down the y from before. That gives me y squared minus 2y, which is minus 4y, plus 4 equals 4. Okay? So that's my equation, and I'm going to try and solve for y. And since it says y squared, I know I could use my methods of solving quadratics to do this. So on the left side, I'm going to combine like terms, and I'm going to put it in standard form. So the y squared will come first, and I could do y minus 4y. Y goes. Hey. $430? Maybe? I don't know. Alright. Okay, so I have y squared, and y minus 4y is negative 3y. And I'm going to bring down the plus 4 and the equals 4. So to solve quadratics, the easiest way for me is to try and get it equal to 0 and factor. So if I look at this, I can actually take that 4 that's on the right, and I can move that over to the left side. And when I subtract that 4, it's actually going to give me 0. So I'm going to get y squared minus 3y equals 0. So now I have two values of y that I can solve for. I'm going to factor y squared minus 3y. I'm going to factor out the y. That gives me y times y minus 3 equals 0. So now that I have it completely factored, I can split up the factors and set each one equal to 0. So I have y equals 0, that's one y value, and I have y minus 3 equals 0, giving me a y value of 3. So I have two y values that I can use. What I need are the corresponding x values. So I'm going to pick which equation is easiest for me to substitute. I think using y equals x squared is the best decision here, because I don't have to deal with all of the other arithmetic in the second equation. So in order to find the corresponding x values, I'm going to use y equals x squared. Okay? So I substitute in each y value one at a time. All right? So I'm going to start with 0. To solve 0 equals x squared, I take the square root of both sides, so I'm using the square root property, right? And if I take the square root of both sides, technically my answer is positive or negative 0, but since 0 has no sign, the x value that goes with that y value is 0. So one of my points of intersection is going to be 0, 0, the origin. But I still need to find what goes with that y value 3. This is where it gets a little bit different. So if I put in 3 for y, I'm solving 3 equals x squared. So by utilizing the square root property, to solve that equation 3 equals x squared for x, I take the square root of both sides. Now technically, when I take the square root of 3, even though it's an irrational number, it could still be a positive or a negative version of that number. So the square root of 3 is really the positive or negative square root of 3, and that equals x. So I got two answers there, which means that there are two more points of intersection. It could be the x value positive root of 3 with the y value 3, and the negative root of 3 with 3. So my three answers are 0, 0, then I have the positive root of 3, comma 3, and I have one more point, which is the negative root of 3, comma 3. Okay, I'll write that as a solution set. And then we're all done. So if you were to actually graph this on graph paper, these graphs would intersect 3 times at 0, 0, 3, 3, and at negative 3, 3. So now knowing that and how that's possible, now that you've watched the video, what I want you to do is go onto the WordPress site and complete the Google form to rate your understanding of the lesson. Thank you for watching.